Inverse functions. In this chapter, we're going to discuss inverse functions. So first, we're going to recall what do we mean by a function. A function is a relation between two sets where every element in the domain is related to one element in the range. So every element in the domain should be related and related to one element in the range. Now we call the first set the domain, and the second set the range. Now keep in mind, we can have two elements in the domain, as we see, related to the same element in the range, but we can't have one element in the domain related to two elements in the range. Now we're going to define what do we mean by one-to-one function. One-to-one function, it means every element in the domain should be related to one element in the range and vice versa. So every element in the domain should have exactly one image, and also every element in the range should have one pre-image. So that's an example of one-to-one function. Now why we're studying one-to-one function? Because these are the only functions that have an inverse. Now let's see a counterexample of one-to-one. So this is not one-to-one. Now why? Because 2 is related to B, and also 3 is related to B. So this is an example of not one-to-one. So such function does not have an inverse. Now, speaking about inverse function, we're bringing back our one-to-one function. How does the inverse looks like? So this is our function. Now the inverse is going to be from A to 1, from B to 2, from C to 3, and from D to 4. So this is my inverse function, and this was my function. Now let's compare the domain and range of both of them, and this is a very important property. Now notice the domain of the inverse is the same as the range of the function. Similarly, the range of the inverse is the same as the domain of the function. So this is a very important property, and so you don't have to, once you find the domain and range of one thing, you can state the domain and the range of the inverse. So let's see an example where we have to indicate the inverse. So we have the following function. First of all, you need to detect if this function is one-to-one. Now this one is one-to-one. I don't see any repetition in the domain or the range, so this is one-to-one. Therefore, the inverse, just switch the coordinates of x and y. Just swap the coordinates of x and y. Another example. Now notice this one is not one-to-one, therefore no inverse exists here. Now what if I have a graph? How can I tell if a graph is one-to-one? Because if a graph is one-to-one, it has an inverse. So we have the horizontal line test. The horizontal line test states you need to draw a horizontal line. If it intersects the graph at one point, then the graph given is one-to-one. So we're going to draw a horizontal line to each of these graphs. And notice only the first one and the last one are one-to-one function, therefore they have an inverse. Now, how do we graph the inverse? So we have the function 2x minus 3. This is a straight line with y-intercept -3 and slope 2. There is a very important property about the function and the inverse. They are symmetric with respect to y equal x. Y equal x is a straight line that passes through the origin and divides my plane into two congruent parts. Now we're going to take 2 points. So, and you can take any 2 points you want, but I took the y-intercept. Now switch the coordinates. That's -3, 0. And I took another point, which is 1, -1. Switch the coordinates. That's -1, 1. Now this is a linear function, so the inverse is also going to be a linear function. So we only need 2 points. And the orange line is the graph of the inverse. In this example, we're going to graph the inverse of the cubic function shifted to the right 3 units. So we're going to start by taking points, but keep in mind that the function and the inverse are symmetric with respect to y equal x. So the first point is 3, 0. Switch the coordinate, it will become 0, 3. Then the second point is 4, 1. Switch the coordinates, it will become 1, 4. Another point, 2, -1. Switch the coordinate, it will become -1, 2. Now draw the inverse. So this is the graph of the inverse. Keep in mind, the graph of the inverse and the function are symmetric with respect to y equal x. Another example. So we're going to start by taking points and we're going to switch the coordinate. So this one, 1, 5, it will become on the inverse as 5, 1. 4, 4, switch the coordinates, nothing happens. So this point belongs to the function and the inverse. This one is 0, 4, switch the coordinates. 4, 0 will belong to the inverse. -4, 0, switch the coordinate, it will become 0, -4. And finally, -6, 1, switch the coordinates, it will become 1, -6. So the blue points, all of them belong to the inverse. Now draw the lines. So this is the graph of f of x, and this is the graph of the inverse. Another example, keep in mind y equal x squared, if we took it all, it doesn't have an inverse because it doesn't pass the horizontal line test. So we only took the part that is greater than 0. We only took the part that is greater than 0. And we're trying to find the inverse of that part. So this is the part that is greater than 0. We don't need the other one because we can't have the inverse. So we started by taking points 0, 0, 1, 1. Even if we switch the coordinates, the result belongs to the inverse. 2, 4 will become 4, 2. This is y equal x. And this is the graph of the inverse. So the orange one is the graph of the inverse, which is square root of x. Very important property of inverse function. If we take the composition of a function and the inverse, the answer is x. Now this is the linear function that we graph the inverse. Now we're going to find the equation of the inverse. So first we're going to write f of x as y. We're going to swap x and y. So whenever you see y, write it as x, and whenever you see x, write it as y. Now we need to solve for y. So we're going to add 3 to both sides. Then we're going to divide every term by 2. Now we're going to write y as f of inverse. And that's the inverse. Now we're going to see application to that property. We're going to take the composition both ways, and we're going to see we're going to obtain x. So we're going to start with this one, and keep in mind we're taking the composition of the function and the inverse to see if we're going to get x. We start from inside, then we go outside. So first we started from inside. We substituted the inverse by the expression it represents. Then we went to f and replaced that by x. And notice, after simplification, we got x. Now we're going to do it the other way. So we started from inside. We replaced f of x by 2x minus 3. Then we went to the inverse and we replaced that expression by x. After simplification, the answer is x. So we got x both ways. It means these two are inverse. Now we know they are inverse because we just have calculated the inverse. Now we need to find the inverse of this function. So first we're going to write f of x as y. Then we're going to swap x and y. Whenever you see y, write it as x. And whenever you see x, write it as y. Now we're going to solve for y. So we're going to start by subtracting 6 on both sides. Now we're going to take the cube root to both sides. And we're going to write y as the inverse function. Now we're going to verify our calculation by using the property of a function and the inverse. So we're going to take the composition of the two expressions we got. So first we replace the inverse function by the expression it represents. Then we went to the function and replaced that for x. After simplification, we got x. Now we're going to take the other way. So we started from inside and we went to the inverse and replaced that for x. Notice we got x both ways. It means the function and the inverse are inverses. Now in example number 10, we need to find the inverse of y equal x plus 8 over x minus 1. So here right away we can swap x and y. We're going to cross multiply. And we're going to distribute the x. So x times y is xy, x times negative 1 is x. Now we're going to group the y. So we're going to add x to both sides and subtract y from both sides. Now we're going to factor out y. And we're going to divide both sides by x minus 1. Now we're going to write y as f of inverse. So we're going to check if f and g are inverses. So we're going to take the composition. Keep in mind, we start from inside. So this is my f of x, but I need f of g of x. Now take out g of x, write the expression it represents. After simplification, the answer is x. Now we're going to do it the other way. So this is my g of x, but we need g of f of x. Take out f of x and write 3x minus 7. After simplification, the answer is x. We got x both ways. It means f of x and g of x are inverses. Another example, we're going to take the composition. So this is my f of x, but I need f of g of x. So take out g of x and write x plus 4 over 2. After simplification, the answer is x plus 8, which is not equal to x. Therefore, they are not inverses. So that's all for this chapter. Thank you for watching.